Imagine you've just inherited this ticking time bomb,
Oh, boy.
right? It's this massive, completely undocumented software system, and it processes like millions of dollars in customer transactions.
No pressure.
Yeah, exactly. Zero pressure. Because the developer who built the whole thing, he vanished 3 months ago.
Just gone.
Just gone. So you have no map, you have absolutely zero instructions, and here's the kicker. You have a hard deadline of this coming Friday to add a massive new feature.
That is just a universally terrifying scenario.
It really is. If you fail, the company loses money. If you touch the wrong thing in a panic, you might, I don't know, accidentally break tax laws across Europe.
Which happens.
It does. You're just staring at a screen full of completely foreign logic, the clock is ticking, and you literally have no idea where to even begin.
And that paralyzes people. I mean, totally freezes them up. And it's not because they lack the technical skills, or the intelligence. It's just because they are completely lost in a maze that somebody else built in the dark.
Which perfectly sets the stage for our deep dive today.
Yeah, let's get into it.
We are exploring these incredible excerpts from a piece called The Secret Life of Claude Code Reading, Code You Didn't Write. It's by Aaron Roth, published on tech-reader.blog.
It's a fantastic read.
It really is. And our mission for this deep dive is to figure out exactly how you orient yourself in an unfamiliar, messy system.
Specifically using AI, right?
Exactly. Using AI like Claude Code as a tool to map out the chaos. But, and this is crucial, without losing your own critical judgment.
Or getting lazy, because that's the trap.
Right. You can't just outsource your brain. And this is such a vital modern skill because, whether you're a programmer writing software or maybe a manager taking over a struggling department.
Or even someone just trying to decipher a really complicated shared spreadsheet.
Yes, the nightmare spreadsheet. We all have to navigate the systems we didn't design. And the source material illustrates this so beautifully through a little narrative.
It does. Aaron Rose paints this incredibly vivid scene.
Yeah, set the scene for us.
So we're in this grand Victorian library in London. It's one of those quiet, imposing places. You can practically smell the history.
The leather-bound books and dust, yeah.
Exactly. You feel the weight of old decisions. And we meet Margaret. She's a veteran senior software engineer, and she's there with her junior colleague, Timothy.
And Timothy is like in full-blown crisis mode.
Oh, completely melting down. He's inherited this billing integration code base from a developer named Marcus. And Marcus left the company back in February.
And Marcus, staying true to form for developers rushing to meet a deadline, did not leave a map.
No map at all. Zero documentation.
That's nothing. Well, okay, there are a few scattered comments in the code, but they only describe what the code does, right? Not why it does it.
Which is the most frustrating thing. And the stakes are high. The product team needs a brand new payment provider added to this integration by the end of the month.
And Timothy confesses to Margaret that he's been staring at this code since Monday. And today is Thursday. 4 days of just staring at a screen, sweating.
But what's fascinating here is Margaret's reaction to him. She doesn't question Timothy's coding ability, not for a single second.
Right. She doesn't think he's incompetent.
Exactly. She realizes immediately that his paralysis, it isn't a lack of technical skill, it's a fundamental flaw in his approach to the unknown.
He jumps straight into the deepest, darkest part of the pool without, checking the currents first.
Yeah, she diagnoses his mistake right away. She says, you started in the middle.
The absolute worst place to start.
Right. He's stuck on this incredibly complex proration engine with wildly interpretive variable names, functions calling other functions in this dizzying loop.
And just so we're all on the same page, proration is basically the math of fairness.
Right. Yeah, that's a good way to put it.
Like, if you upgrade your streaming subscription halfway through the month, the proration engine calculates exactly how many cents you owe for the remaining days.
And it is notoriously tricky math.
Oh, I bet. And he's trying to understand the most tangled, mathematically complex part of the whole system in total isolation.
Which brings up that analogy Margaret uses in the text. I absolutely love this part.
Oh, the novel analogy, yes.
Yeah.
She says most developers approach unfamiliar code the way they'd approach a novel that someone just left open to page 200.
Right. Imagine doing that. You just pick up a book, start reading on page 200.
You have no idea who the characters are.
You don't know the setting. You lack all context.
So what do? You get confused. You flip back a few pages to try and figure it out. You get even more confused. And ultimately, you just assume the book is terribly written.
It's a brilliant comparison because it really highlights our psychological need for context. Our brains just aren't designed to process isolated logic without a framework.
You need a container for the information.
Exactly. If we connect this to the bigger picture, you simply cannot evaluate code or any complex system, really, if you don't yet have a mental model for it.
Right. Before Timothy can sit there and read the precise logic of how that proration is calculated, he needs to understand what proration is actually behaving like within the broader system.
He needs to know what the story is about. Who is the protagonist? What's the genre? Before he starts critiquing the grammar on page 200.
Yeah, you have to build the model first. Otherwise, your brain has literally nowhere to file the information you're reading.
You're just holding raw, unconnected data in your working memory until, boom, cognitive overload hits.
Your working memory overflows and you panic.
Exactly.
Okay, so if diving into the middle of the code is the exact wrong move, I'm guessing Margaret has a specific framework for where Timothy should start.
She does. And this brings us to Margaret's actionable strategy. She introduces a rule she calls the 2 passes.
There's 2 passes.
Yeah, and she makes a real point to note that most people completely skip both of these passes, and they pay a heavy price in lost time and frustration.
Let's get into the weeds on this then, because pass 1 is called the map pass. Margaret tells him, look, you are not reading code right now. You are reading structure. You look at file names. You look at how the directories are organized. You look at function names. But you explicitly do not look inside the functions to see how they work.
It's like if you inherit a massive, messy company Google Drive, you don't start by opening a 50-page strategy document from 2022.
No.
You start by just reading the folder names to see how the previous manager categorized their brain.
That is exactly it. You are looking at what the system values. What did the original author choose to name? How did they group concepts together?
And the text gives these great specific examples. You look for names like prorate charges, apply credit, calculate mid-cycle delta.
You're actively building a vocabulary. Because before you read a single line of how it actually works, you need to be able to describe the system using its own native language.
And this is exactly where a tool like Claude Code becomes immensely powerful.
Yes. Not to do the reading for you, but to massively accelerate this map pass.
Right. Instead of manually writing down all these folder names, you use the AI.
But what does a good prompt for that actually look like? Because if you just say, tell me what this does, that seems way too broad.
Oh, it is too broad. To get real value, you need what you might call a power prompt. You take that structural information, the directory trees, the file names, you paste it into Claude Code, and you prompt it like this.
Okay, let's hear it.
You say, act as a senior systems architect. Review these directory and file names. Based strictly on the structure, tell me what core business concepts you suspect live here. What is the vocabulary of this system? And crucially, point out what major context I appear to be missing.
Oh, that's smart. You're asking it to identify the gaps in the map, not just the roads.
Exactly.
Okay, so I have the folder names, I have the vocabulary, I have the map. I'm guessing I don't just start reading the whole map from top to bottom. Do I trace a specific route?
You trace a route. Margaret calls this pass 2 the flow pass.
The flow pass.
Yeah. Once you have the map, you don't just start reading everything left to right. You pick one complete path through the system. For example, you take one single webhook event.
And just to clarify for everyone, a webhook is basically an automated digital knock on the door, right?
Yeah, that's a perfect way to describe it.
It's one system telling another system that something just happened, like a customer hitting buy on a website.
Exactly. So you take that one digital knock on the door, or maybe one specific subscription renewal process, and you follow that single thread from the very moment it enters the system to the exact moment it exits and updates a database.
You're tracking a single package through the whole factory, rather than trying to understand every single machine in the factory all at once.
Right. And again, Claude Code can assist here. You paste in the relevant files for that specific path and ask the AI, trace the execution path of this specific webhook. What is the code doing along this specific route, step by step?
Okay, I have to push back here a little bit.
Sure.
Because if I'm listening to this and I want to save time, wait a minute. If I just ask the AI to map the whole structure, and then I ask the AI to trace the flow of the data and summarize it for me, hasn't the AI just solved the problem?
Like, why can't I just blindly trust its summary, pat myself on the back, write the new feature based on that summary, and take a long lunch?
That is the ultimate trap.
It is.
Oh, yeah. And it's one of the most common ways developers introduce catastrophic bugs today. Margaret is very firm about correcting that assumption.
Okay, why?
This raises an incredibly important question about the difference between a hypothesis and a fact.
Ah,
When you use an AI model to read unfamiliar code, it is giving you a hypothesis. It's an educated guess based on patterns. It is not giving you the absolute truth.
because the AI has major blind spots.
Massive ones.
Yeah.
Large language models read what is physically there right now. They analyze the text. Claude Code does not know why Marcus made those decisions a year ago.
Right.
It doesn't know about some obsolete business requirement from the CEO that forced the code to look a certain weird way. And crucially, it doesn't know if a previous developer updated the actual logic of the code, but just completely forgot to update the human-readable comment sitting right above it.
It takes the text at face value.
Yeah, there's this analogy Margaret uses for this in the source that just clicked everything into place for me.
The city map.
Yes. She says you have to trust the code and the AI's reading of that code the way you trust a map of a city you've never visited.
It's probably mostly accurate.
Mostly, yeah. But there might be roads on the map that are closed for construction, or new one-way streets that aren't on the map at all. You use the map to navigate, but you still have to look up through the windshield and see what is actually in front of you.
Which means you must test the hypothesis. If the AI tells you this function calculates proration by comparing the days remaining to the total days in the month, your reaction shouldn't be, awesome, I know how proration works.
No.
Your reaction must be, is that actually the correct way to calculate it for our specific product? And does this code really do that in every single scenario, including leap years?
Right, you have to take the AI's output and test it against real-world inputs. You have to hunt for the edge cases. And sure, the AI can help you brainstorm those test cases. You can ask it what inputs might break this logic. But at the end of the day, you are the human in the loop. You have to decide if those are even the right questions to be asking.
Because the AI doesn't carry the messy context of the real world, which brings us to a really fascinating part of their conversation in the library. Why code is so hard to read in the first place.
Yeah, Timothy asks about this. He's like, when code is just incredibly hard to follow and looks like a tangled mess, isn't it usually just some arrogant developer trying to show off and be overly clever?
Or maybe a mountain of layered legacy decisions.
Or honestly, just a flat-out mistake.
It can be all of those things. But Margaret drops a massive insight here, especially regarding the billing system Timothy is working on. In billing systems, strange, convoluted code is very often compliance.
This is such a great point. What looks like bad coding is actually the law.
Exactly. Tax laws vary wildly by jurisdiction. Payment processors have bizarre constraints that make zero sense from a pure business logic standpoint.
And PCI compliance, right?
Right. Yes. PCI compliance. Those are the incredibly strict security standards required for handling credit card data. It leaves these weird fingerprints all over the code. To an outsider, it looks completely arbitrary. But it's actually protective scar tissue.
It's like moving into an old house and finding a light switch installed upside down, hidden behind a door.
Yeah.
At first, you look at it and think the original builder was a complete idiot. But then you do some digging and realize it was literally the only way to pass the 1990 fire safety code without having to tear out and rewire the entire floor.
That's a perfect analogy.
It's ugly, but it's keeping the house from burning down.
And Margaret's ironclad rule is, you should never, ever refactor strange code until you know exactly why it's strange. If you just tidy it up to make it look elegant and pretty, you might accidentally break tax compliance for half of Europe.
Which is a career-ending mistake. Okay, so let's take stock of where Timothy is on this journey. We have a map of the structure. We've traced a single flow. We know not to blindly trust the AI's hypothesis. And we know to respect weird, ugly code because it might be a load-bearing compliance wall.
Right.
But Timothy is still staring at that messy proration engine right in the middle of the system. He still has to change it. How do we actually survive the middle?
Margaret gives him 3 very concrete strategies for tackling the hardest, most opaque parts of a system. The first is trace from the known.
Right, so Timothy knew how that initial webhook handler worked.
Yeah.
That digital knock on the door was clear to him.
Exactly. So Margaret tells him to start at that stable point, the shore, basically, and follow just the immediate next step. Don't look at where the data ends up 10 functions down the line. Just look at the very next leap. You build your understanding outward from a place of absolute stability, one function at a time.
Step by step, instead of jumping to page 200. Strategy number 2. Read the tests. And this was fascinating to me. Marcus, the developer who left, actually wrote automated tests to check his own work. And Margaret points out that tests are actually the truest form of documentation.
Because they describe what the system is supposed to look like from the outside?
Oh, I see.
The text gives a great example. A test might literally be written in plain English as, when a subscription upgrades mid-cycle, the prorated charge should equal the per-day difference times the remaining days.
That one sentence tells you the intention of the code far better than the messy math buried inside the implementation.
Exactly. And this is where the mechanism of AI gets really interesting. Margaret advises Timothy to have Claude code read the tests, not the messy implementation.
Why does that work so much better?
Because large language models are, at their core, pattern recognition engines. When you feed an LLM the raw, messy implementation code, it gets distracted by the spaghetti, the compliance scar tissue, the weird workarounds.
It gets lost in the weeds.
Right. But a test is pure logic constraint. Input X must yield output Y. By having the AI read the tests, it bypasses the messy human implementation. It allows the AI to reverse engineer the perfect version of the rules in its digital mind. You're getting an independent read of the system's specifications.
Using the AI to reverse engineer the requirements from the tests. I love that. Okay, the third strategy for surviving the middle. Disciplined experimentation.
At a certain point, reading isn't enough. You have to poke the system to see how it reacts. You have to make small, reversible changes in a safe, local environment while running that test suite.
But the stakes here are real. The source text specifically highlights this. In a billing system, an uncontrolled experiment doesn't just mean your code fails to compile.
No, it means real consequences.
It means a real human customer out in the real world gets charged the wrong amount of money on their credit card.
Which is why the experimentation must be disciplined. You form a hypothesis, you make a tiny tweak that would prove or disprove it, and you let the test suite be your safety net. You never guess, you verify.
Okay, as we follow this narrative, I realized something was missing.
What's that?
Even with the map pass and the flow pass and tracing from the known, Timothy is still missing the intent behind the code. He knows what it does, but not the why. Which brings us to what Margaret reveals as the true beginning.
Yes, this is the most profound revelation of the entire piece, and we really need to spend some time here. The very first day of inheriting a new system shouldn't involve reading code at all.
Wait, really?
It should be dedicated to digital archaeology.
Digital archaeology. Tell me about this, because this completely reframes how I think about inheriting projects.
Before you look at how a system is built, you have to look at the history of how it evolved over time. You start by reading the commit history.
And for those unfamiliar, a commit is basically a save point. When a developer saves a chunk of work to the main system, they attach a tiny little note explaining what they just did.
Exactly. And you look for patterns in those save points. The text points out that if a single file has been modified 15 times in the last 2 years, that file is screaming at you.
It's radioactive.
It is trying to tell you that something is inherently volatile or contested or highly complex about that specific area. And the commit messages themselves are clues. A note that says, hotfix, edge case for annual subscribers in EU.
Wow.
That one little sentence carries so much lost context that the raw code itself will never, ever tell you.
But Margaret doesn't stop at commit messages. She points Timothy to the absolute goldmine of digital archaeology, pull requests or PRs.
Right. When developers propose adding their new code to the main codebase, they open a pull request. And this is where the human element enters.
The drama.
Yes. There is usually a discussion, reviewers ask questions, the author defends their choices. There is a back-and-forth debate.
Margaret says it's the closest thing to actually sitting next to Marcus. Because think about the psychology of a pull request. It's a negotiation. Let's imagine a scenario. Marcus submits code, and another developer comments, hey, this proration math fails on leap years.
Yeah.
And Marcus replies, I know, but the payment provider's API literally rejects leap year calculations, so the VP of Finance told us to just round down and issue manual credits.
Yes.
That kind of heated, messy argument, that is the real documentation. It's the human story and the business constraints behind the machine logic.
And if you don't read that argument, you will step on the exact same landmine Marcus did. And here is where you can truly leverage AI for archaeology.
Because reading 40 comment threads of developer arguments is exhausting.
It's awful. But you can feed those lengthy, messy PR threads into Claude Code and ask it to synthesize the debate.
Another power prompt. What does that sound like?
You prompt the AI, review this pull request discussion, summarize the core disagreement. What specific business problem was this change trying to solve? And what underlying assumptions or constraints were the developers forced to accept?
That is so good. You are using the AI to extract the reasons for decisions, filtering out the noise to find the actual constraints.
It's incredible. Think about the journey Timothy goes on in this library over the course of the afternoon.
Yeah, he starts out just staring blankly at a wall of incomprehensible text, feeling entirely defeated by a machine.
And by the end, he is performing digital archaeology on human decisions from months ago. He's building structural maps, he's tracing data flows, he's using AI to reverse engineer tests, and he's interviewing the ghost of the past developer through old pull requests.
He fundamentally shifted his mindset. He stopped trying to decode a machine in isolation and started trying to understand the humans who instructed the machine in the first place.
Which leads us perfectly to the final, lasting lesson of this deep dive.
We're back in that London library. The gray afternoon is persisting outside. Timothy finally understands that reading unfamiliar code is about patience. It's about map building. But as he's packing up his laptop, Margaret leaves him with one final, very specific instruction. She says, once you figure all this out, write it down.
But not for himself, and not for Marcus.
No, for the next person. Because inevitably, someone else is going to be standing exactly where Timothy is standing right now. And they deserve better than 3 days of agonizing confusion before they find their footing.
It's such a powerful takeaway, because if we connect this to the broader reality of modern work, this matters to all of us.
Oh, totally.
It doesn't matter if you are a software engineer inheriting a billing system, a manager taking over a struggling department's workflow, or just someone trying to decipher a really complicated shared spreadsheet that tracks quarterly goals.
Yep.
Understanding any system requires you to respect its history. You have to respect the human decisions, the compromises, and the bizarre constraints that built it. AI is an incredibly powerful flashlight in the dark. But at the end of the day, you are still the explorer. You have to draw the map.
AI is the flashlight, but you are the explorer. I love that. It leaves us with something really important to mull over. Consider just how much institutional memory simply vanishes into thin air the second someone leaves a job.
So much of it.
If the true blueprint of a project isn't in the official manuals or the polished final documents, but is actually hidden in the messy, day-to-day back and forth of everyday communication like pull request debates or buried Slack threads or quick email justifications, how might you change the way you write a simple project update today? Knowing that your quick message today might be the only archaeological artifact someone else has to rely on tomorrow when they inherit your massive, undocumented mess.